Hello guys, welcome to a new video. Today we're going to be talking about oxidation and reduction in digestion. So to touch on the basis, what's oxidation and reduction reactions, right? Oxidation reaction is a reaction where something is like losing electrons, right? The oxidation is the loss of electrons. The way that I like to remember the oxidation is the loss of electrons is that when metals they get oxidized, they become ugly. That's why I remember like oxidation looks ugly, right? So oxidation looks ugly, so that it's like a losing, right? And reduction is the gain of electrons. The way that I remember the reduction, it's the gain of electrons, is that electrons have a negatively charged, right? So if you're getting too much negative of something, you're getting reduced. What is digestion, right? Any definitions that we give, the citation is gonna be in your top left, right? So according to the Merriam-Webster dictionary, digestion is the process of making food absorbable, right? So like making food absorbable so we can release energy with, right? By mechanically or enzymatically breaking it down into simpler chemical compounds into the digestive tract. Digestion is a process where we get food, right? And we break that food down to make energy, ATP. So where does redox reactions come into the game, right? So redox reaction is a combination of reduction plus oxidation reactions. In digestion, there is multiple parts, the reduction and oxidation reactions come into play to make digestion happen. Jesus, why is there so much stuff in the board? Don't worry, we'll see really quick. Okay, so we're gonna take this step by step and we're gonna be like erasing parts. Everything is extremely oversimplified, okay? So digestion, right? In digestion first, digestion starts whenever we see the food, right? We see food and we start salivating. Even the type of food, if you think of a burger right now, you will start salivating, right? So it starts at salivation. Okay. It starts at salivation, right? So after that, in your mouth, after salivating, all your saliva, you're eating the food, and you have enzymes in your saliva that will help you break down those food into smaller pieces. The carbohydrates, this is a polymer, it will break down into a monomer like a sugar, right? And after that, from the mouth, it will go to your stomach, right? From your stomach, in your stomach, other proteins become into amino acids. Again, a polymer into a monomer. Into the small intestine, is where all the polymers start, like, end up becoming monomers. Fats, carbohydrates, and proteins. Polymer to monomer. So finally, from the small intestine, all the nutrients that you already absorbed so far, they will go into your bloodstream, and from your bloodstream, they will go into your cell. So again, this is oversimplified. This is like extremely oversimplified. So oxidation and reduction reactions, they always happen together. It's like, for something to be oxidized, the other stuff has to be reduced. For somebody to hurt someone, somebody has to get hurt. Somebody has to be the aggressor. It's the same concept. Oxidation and reductions, they always happen together. So we're going to be talking about oxidation and reduction during cellular respiration, right? So from your small intestine, it went to your bloodstream, and on your bloodstream, it goes to your cells. And that's called cellular respiration. In cellular respiration, you want to break down glucose to make energy. That's how, because we need energy, right? All humans beings, all the emotions, they need energy. And where do we get them? From food. Okay, so I'm gonna start by breaking down ATP, right? Adenosine triphosphate, right? I'm gonna start from breaking down its structure, which I think is really interesting. So this is adenine, right? It's also a nucleotide found in DNA, which is crazy. I think it's really interesting because we learn about the nucleotides found in DNA, like adenosine, like adenine, right? We made like that's U is for RNA, with A, T, G, C. Those are the four. So one of them is gonna be here, adenine. Its main like base, right? A nucleotide, and its main base is here. So that's gonna be adenine, and it's gonna be connected to a ribose. Remember, ribose are pentose sugar. What's a pentose sugar? It means it has like, bro. If we recall geometry, this is a pentane, right? So that's what it means. It's a pentose sugar. So ATP is gonna be the adenine base with which is a nitrogenous base, right? Because you can see the little nitrogens here. That's why it's called nitrogenous base. So it's gonna be the nitrogenous base connected to a sugar, the ribose specifically, to a 3-phosphate groups. I was just too lazy to write the phosphate groups. We just imagine 3 phosphate groups, and this is where the energy comes from, right? Whenever those phosphate groups, the bonds break, there's a huge amount of energy stored in those bonds. So that's what ATP is gonna be. It's gonna be nitrogenous base with a sugar with a phosphate group. Okay, you see there is less stuff in the board, which is greatness. Okay, so we go back to cellular respiration, where we want to have oxidation and reduction reactions, right? So we start from left to right. So glucose over here, for glucose, all of these corners are representing a carbon. That comes from organic chemistry. If you have some troubles looking at that, you can watch some of my organic chemistry videos, right? And you have a bunch of alcohols, right? So you want to have C6H12O6. That's going to be your structure for glucose. And you want to plus 6 O2s, right? And it's going to be coming to carbon dioxide, which is being reduced, and water. Right? So glucose, oxygen, water. Glucose is being oxidized. Carbon dioxide is being reduced. So here I introduce you to, I hope you can see, let me see, to hydrogen. Hydrogen is made of 1 proton and 1 electron. So oxidation is the loss of electrons, and reduction is the gain of electrons. So what we're trying to say, right, is this. Okay, so glucose was brother on Christ. Glucose was C6H12O6. 1, 2, 3, 4, 5, 6. Yeah, O6. Man. So what we're trying to say is that it's losing an electron. Therefore, this time hydrogens are going to be electrons. Even though it comes with protons, we're only focusing on the electron part. So that's why glucose is being oxidized, because it's losing its electron. So if we think about it, glucose, 6,6, is being transformed into the carbon dioxide, and it's losing its hydrogen, right? So its hydrogen, oxygen being reduced, right? Oxygen is being reduced and it's gaining the hydrogen, so gain of electrons. To get water. So Glucose is being oxidized and it's becoming to carbon dioxide, right? It's losing its hydrogens, and oxygen is being reduced, right? And it's gaining the hydrogens, it's transforming to water, and we have ATP. Okay, so I hope I got it right. So this is my right, and it was so it should be in the left of your screen. In the left of your screen, you will be seeing a question right here. And this question is, your body extracts energy from the food you ingest by catalyzing reactions that essentially burn the food molecules in a stepwise fashion. What's another way of describing this process? Okay, so we just talked about how the glucose molecules, right, are oxidized and they become the glucose, the molecules get oxidized, right? So the answer for this will be, I don't know what the answer is, will be oxidation. And that's because the glucose molecules are oxidized. Oh, this will be all for today. I hope you have a great day. If you have any ideas for videos, let it down in the comments. If you have any suggestions, let it down in the comments. I really appreciate everybody. Give a like and subscribe.